Hi guys, we are doing the 10A part 2 notes, and we're on example number 5, okay? We are asked to set up the trig ratios by identifying sine, cosine, and tangent of angle theta. And you'll see on this problem, we don't have our template like we did on problems 1 through 4. And that's because sometimes you're going to be given a problem where you have to make the template. And so I want to walk through that process with you guys. Again, we have a nice little way to remember what our trig identities are. So, ka, toa, that's how we say it. Okay? But the way I like you guys to write it is like this. So, ka, toa. Okay, this is a great way to remember the important trig identities, sine, cosine, and tan. So that when you're asked to give those ratios, you know that the sine of theta, you want a ratio for that one. You want the cosine of theta, a ratio for that, okay? And then the tan of theta, a ratio for that, okay? And you remember that because you remember this SOHCAHTOA, all right? Now, let's get started with this particular problem. Of course, what we want to do is label. And you guys are pros at this by now. This long side that's directly across from the 90-degree angle, we label with a big capital H. That's our hypotenuse. These two legs that make up our 90-degree angle, we don't label as legs anymore, do we? We have to distinguish them as either opposite from theta or adjacent to theta. And that adjacent, of course, means next to. Okay? Next to. And that is what you guys are going to remember when you're identifying which side is adjacent. The adjacent side is next to theta or touching theta. All the way across from theta, not touching theta, is our opposite side that we label with a capital O. Now we can see that we have lengths for two sides. Those are our legs. We're missing the length for our hypotenuse, just like we did on previous examples. This gets labeled with an X now, and we are going to use the formula from the Pythagorean Theorem to find what X is. Now, of course, you guys remember that the formula from the Pythagorean Theorem, a squared plus b squared equals c squared. The other way to think about that is just leg squared plus leg squared equals hypotenuse. And that's because, of course, c is always the hypotenuse. Doesn't matter which leg goes which place here, but C has to be the hypotenuse. And so when we're looking for a missing side, X is always that missing side, but sometimes X is a leg, sometimes it's the hypotenuse, right? So be super careful about that. 13 squared is what is one of our legs. The other leg is 4, but in our formula, we're always squaring it. We're adding that to the 13 squared. X is the missing length on our hypotenuse, so everything's going to be equal to X squared. 13 squared, do it on your calculator, guys. It's going to be 169. Oops. Then 4 squared, of course, is 16. And then we're equal to X squared. We're going to add these two together. 169, we're adding it to the 16, and that's going to give us a 185. And in order to find the side length, we need X. So we need to take the square root of both sides. And that'll give us the square root of 185 is equal to X. Now, can we simplify this? Well, let's look at our calculator. 185 square root, oops, gives us a decimal. No decimals on these guys, but you can do what we have done before, and that is do our prime factoring on our root 185. So if you want to leave it like this, I'm not going to count it wrong, but I would prefer it if you guys did a prime factorization of this root. And I know that I'm going to not go 2 because 5 is not divisible by 2. Same with 3. But when your last number is a 5 or a 0, try 5. That's the first in the list of prime numbers that we know for sure will be divisible into 185. Okay? So then, of course, back to the calculator. And we'll just go 185 divided by 5. And that'll give us 37. Okay, so when we do, sorry guys, I wrote 5 and 185, but actually what we just saw is it's 5 and 37. So when we divide 185 by 5, it gives us 37. So that's the other factor. Now, look, this is prime, and guys, 37 is prime as well, isn't it? And so because 37 is prime, we can't simplify this, all right? So then x will just equal square root of 185. And then we want to be sure to take that right back and plug it in for x, okay? So we're going to take that square root of 185 and plug it in for x. So when we do these trig ratios, the sine of theta is going to be opposite, or 4 over hypotenuse 13. The cosine of theta is adjacent over hypotenuse. Oops. Opposite. Oh, I messed up here, guys. So sine of theta opposite over hypotenuse, instead of, not over 13, over the root of 185. For the cosine of theta, we want adjacent, or 13, over hypotenuse. And then for the tan of theta, we want opposite over adjacent, or 4 over 13. Now, guys, I'm not going to count it wrong like this, but we really don't like to have radicals in the denominator. And to get rid of that radical in the denominator, what we do is we just multiply by 1, or in this case, 185 over 185. Square root of 185, rather, over the square root of 185. And what that does, of course, that's by 1, so that's not going to change anything, mathematically speaking. But what it will do is it will give us, on the top, the root of 185, which is fine. We don't mind those roots on the top, do we? And on the bottom, we'll end up with the square root of 185 times itself, okay, squared. And what that means is we can rewrite that square actually does away with our square root. And so what we end up with is going to be just that 185. Now, once again, I'm not going to count it wrong like this, but for those of you guys moving on to Math 3, I really want you guys to remember we don't like those radicals in the denominator. And so you're going to rewrite that using this technique, right? And this is how you would end up with your trig ratios. Okay, thanks for watching, guys.